I'll just start by introducing OpenTEAM. For those of you who don't know, we're the Open Technology Ecosystem for Agricultural Management. We're a project of Wolf's Neck Center and currently funded in part by our partners and the Foundation for Food and Ag Research. So we have today part of our in-depth webinar series, which is really meant to build the knowledge base of the OpenTEAM community in a way that fosters coherence and collaboration so that we can better serve our diverse membership. So through this, we really hope to illustrate and document the dynamic nature of our community. And we also hope to inspire and share new concepts and technologies that enable the emergence of new collaborations and technology approaches. So today we have with us Rikin Gandhi, the co-founder and executive director of Digital Green, as well as Vineet Singh, who's the platform architect at Digital Green. And we're really excited to hear more about what you've been doing with FarmStack, and a little bit of background with Digital Green, that they've pioneered the use of agri-tech to boost the incomes of small-scale farmers. And they're building on over 10 years of experience with 2 million farmers across South Asia and Sub-Saharan Africa. And with that, I'll kick it over to you, Vineet and Rikin, and thanks so much for being here. We'll also take about 45 minutes of a presentation and then Q&A afterwards. So thank you everyone for participating.
And thank you so much for hosting. Really appreciate this opportunity to share our work and to connect with the OpenTEAM community. We're certainly super excited to see what kind of collaboration opportunities might emerge out of this. So I'll start off with giving some background on Digital Green and FarmStack, and Vineet will come in to talk more about the technical design of it, as well as do a demonstration of how FarmStack is being developed. So, Digital Green started 14 years ago in India, initially as a part of Microsoft research in a group looking at technology for emerging markets. And from a very academic perspective, we were trying to answer the question, is there a role for digital technology in small-scale farming communities that dominate South Asia and Sub-Saharan Africa? And the model that we researched as a part of Microsoft research and that we subsequently spun off into an independent organization centers around the use of videos that are by and for farmers to share improved agricultural practices amongst rural communities more efficiently. And we do that in partnership with various ministries of agriculture and rural development that exist in these countries and that have large field forces on the ground who typically are already using various types of farmer field school, demonstration plot types of means of agricultural extension, and where these videos of testimonials or demonstrations of best practices by farmers is basically meant to amplify the work that they're already doing in the field. That work has now scaled to 6 countries, India and Ethiopia being the largest, and reaches more than 2 million farmers. And during this pandemic, many of these rural communities who weren't so connected increasingly are, and we've received now more than 60 million views to these videos also online. Now, as these videos are being shown, data is also collected about which farmers are watching what video, what practices they apply, and what their feedback is. And that data and that feedback is used to inform the production distribution of new videos. Now, when we started this work in 2006, there was very few players in these ecosystems that we were working in the global South. But over especially the last 2 to 3 years, there's been a proliferation of many more agri-tech startups. In India alone, there's more than 500 that work on various aspects of the value chain in various geographies and collect data about and for farmers. And where we saw an opportunity to say this work that we're doing on agricultural extension could be all the more impactful if aligned with the work that others were doing on other aspects. But really what was needed was a mechanism to share data across these different actors to drive greater coordination and complementarity. And that's where FarmStack essentially was born, with specifically a focus on thinking about how do we ensure that organizations in different parts of the value chain, digital green included, but obviously many others as well, have the ability to share their data in a trustful way that protects their data interests and provides mechanisms for the farmers themselves to also relate with their own data and to inform the improvement of the various types of services or programs that actors in the ecosystem are involved in. And then on the farmer side, that this ultimately results in greater impact, first going from our historical work of working on agricultural extension in terms of enabling farmers to gain access to more site and time-specific extension advisories, precision ag, so to speak, but also other aspects of the agricultural value chain that can create greater value for farmers if they were able to gain greater control of their data and be able to have the ability to transport that data to service providers or marketplaces of their own choice. And so what FarmStack is a open source protocol to power the secure exchange of data across the agricultural sector. And we're building this decentralized protocol that we'll dig in a lot more into on top of a system that was created by an industry association called International Data Spaces Association. So what we're doing with FarmStack is basically building wrappers around the reference architecture that they've built to specifically address the kinds of challenges that we see with respect to data sharing in the agricultural space. And especially in these markets like India and Ethiopia, they're just now in the last 2 or 3 years really becoming much more digitized. And what you're seeing is that there's a greater fragmentation or siloing of each organization's data sets. And the reasons why organizations don't share data are, of course, similar to what you find in the global north around issues of organizations feeling that they might lose control of their data and that there might be issues of privacy or national security or other proprietary interests that prohibit their desire to share. And they really want to ensure, obviously, that the kind of usage policies that they might codify in legal language when they have an arrangement between a data provider and a data consumer, whether those can be enforceable in code with restrictions, for instance, that data is only used for a particular purpose or service or for a particular duration or perhaps in a particular type of aggregation or anonymized form. And then there's also this challenge that because a lot of this digitized data is relatively new, then there's also questions about who has what data, what is its quality, what is its level of resolution, and how do I do joins across data that might have different definitions with regard to how key parameters are defined. So the primary sort of like center point about a FarmStack is basically a peer-to-peer method of sharing data across two parties and codifying usage policies that the data providers and the data consumers mutually agree to. And this is different from the typical rules-based access control that we're all used to, which tends to be pretty binary, right? Either we share data with somebody or we don't share data. And when we do share data, as soon as we've done that as a data provider, we've essentially lost control of our data because that data consumer can do what they will with that data, whether that is hosting it or making copies of it for their own use. And that, again, is one of the main reasons that we've seen that organizations are unwilling to share. But with usage policies of the type that we're able to build on FarmStack, leveraging, again, this infrastructure of the International Data Spaces Association, is a more flexible type of control, wherein there can be codification of restrictions about data expiry, consent to the data provider before it's used, anonymization, restrictions on particular API level services that data can be used for, the ability to download or post that data can be restricted as per the requirements or data protection constraints that the data provider wants to enforce. So with that, let me pass to Vineet to talk through the overall architecture and then to give you a demonstration on how FarmStack actually works. Vineet?
Thanks, Rikin. Hi, everyone. So, sorry.
Sorry.
Okay. You have. Okay. Yeah. So essentially, the architecture of FarmStack, as Rikin mentioned, is focused on is a decentralized or federated kind of architecture where what you see here in the yellow or brown is what FarmStack is, and what you have on left is, let's say, an organization A, which is a data provider, and wants to give data to organization B on right. They have their own infrastructure in blue, which could be an IT-based kind of a system, files or databases, or it could be an IoT kind of a system. And the organization B has its own infrastructure. What FarmStack provides is its own self-service connectors, which we call as a P2P, as a short form of peer-to-peer connector. And these connectors run on these infrastructure. They can be run by the organization A as well as organization B. And using these connectors, these two organizations can communicate with each other and transfer data. So organization A runs this instance of this connector, which interfaces with the existing database. And then these connectors are authenticated using SSL TLS certificates. And then organization A can also, in addition to that, configure usage policies. The usage policies will define how the data can be used. So it could be something that the data is to be used for a particular application and it is not even downloaded in the database of organization B. So this is entirely the peer-to-peer kind of data sharing platform. In addition, there's an optional service of having discovery services, which are basically catalog, where organizations can publish what data they have, uh, the description of the data, as well as data transformation services. And for that, they can use third-party data model services that, for example, AgroWalk, or it could be a simpler models related to agriculture ecosystem. So what FarmStack is not it is not the data model. It is not this infrastructure that is run there. It is not a central data warehouse where people need to host their data. FarmStack provides a self-service connector that can be installed, that can be run, and that can be paired, which provides a continuous sharing of the data with the enforcement of usage policies. Next slide, please. So, uh, I'll spend few minutes on the architecture of the core component of the peer-to-peer connector, P2P connector. So a P2P connector is essentially a, a container management layer, which can run on a VM or a hardware, and it has essentially three broad containers types. There's a configuration container which maintains the network configuration, what are the workflow rules, and so on. The execution container, which is the core container, is what maintains a data bus, which is like a WebSocket. On top of that, there is a data router. What data router does is it says this data can goes from this point to the next point, and so on. Defines these container points, stoppage points, if you can think of this data bus itself. And then there is a usage control, which enforces and implements the usage policy that this particular data route uh, is complying with the usage policies as are defined. And then there could be custom containers that can have different, that can call different APIs, that can interface with the outside world of FarmStack. So they could be APIs or different services, and there could be different applications that can run among these various custom containers, and there could be as many containers that can theoretically as required. Next slide, please. So how is the usage policy implemented? So essentially, there's a provider connector and a consumer connector, and there's the data source. So in this particular case, let's say data source, the provider connector has interfaces with the data source using a data app container, which basically transforms or fetches the data from the data source and transforms it to be transmitted using the SSL/TLS encryption uh, uh, through the provider connector. The config manager of provider and consumer, they have a defined, they maintain a defined usage policy, which is enforced on the consumer side. So when the data is received by the consumer, what consumer connector does is it has a container, and I can specify that this is the particular application in this particular uh, isolated environment where this particular application can only uh, access this particular data and process it in a way that it is supposed to be. So essentially, what usage policy is doing is uh, defining what is that sequence of this isolated workspace that is there, and what are the applications that can access the particular data, which is, if we think of it without FarmStack, uh, the data would essentially reach, even in a peer-to-peer kind of fashion, it would reach there, but it is in the hands of either a manual intervention, it is in the hands of the user. So going to the next slide. So there's a example use case that we have rolled out in Ethiopia. So there is Ministry of Agriculture that has farmer registry. They have the details about the phone numbers and location of the farmers. And then uh, there's a node 2, which is another data provider, which is a Rust forecast file, which is maintained by CIMMYT. CIMMYT is an organization doing research on wheat, And what they provide is wheat rust is a major disease that causes damage to wheat every season, and they provide a forecast every 10 days. So this forecast is a global model and is run by various uh, uh, nations, and this model gives the what is the incidence rate and what is the severity of wheat rust, uh, and farmer registry gives the details of the farmers. Uh, the consumer here is digital green, which combines the data based on the location. So I have location of where, how much is the damage or the severity of wheat rust, and I have the information about who are the farmers in that particular location. And then both these nodes, they specify their usage policies, uh, and as per that, the data is only accessible to an application, which is a Telegram application, which sends out these advisories using a Telegram bot. So this is one of the example use case of FarmStack that has been implemented. Next slide, please. So policies, what are the possible applications? So right now, there are three broad uh, applications or usage policies that uh, we have implemented or are trying to implement. One is restricted to anonymized usage. So basically, as a FarmStack central theme is to combine two or more data sets to generate more value. There is a need to join two data sets, and typically that happens in this particular case for on the basis of some sort of an identifier. But that specific identifier, is also a personal information which should not be further be processed. So I need to join two data sets, but it can only be joined by a specific identifier, uh, and uh, and this is where uh, the usage policy acts. So example could be, I want to create a dashboard of aggregated data, like how many farmers who have adopted a particular practice saw what kind of returns. Uh, Second is restricted to specific purpose. So like in this particular case, uh, we are defining that this is for the purpose of sending notifications and advisories of what to do in case of wheat rust. So this is the only thing that is supposed to be done. A further example could be that I'm using this particular data and these interactions that are taking place in an anonymized fashion, and using it to train as to what people are doing and what is the further response to it. So I just want to use it for creating some sort of a model. So the output could be that maybe a machine learning model in this particular case. Or it could be restricted to use for a specific time. So agriculture being a uh, uh, seasonal applications, a lot of use is for certain time periods. So the data is valid for specifically for this particular time, and uh, and beyond this, the data provider wants to specify that the data is invalid and the consumer should not have access, and that data is not available to them for further usage. They have to specify, they have to request for data, or the data has to be available from the consumer side for the application to run. Uh, One of the things that we would like to uh, also hear and take feedback would be what would be the further usage policies, which could also relate to a larger set of data policies that can be implemented using this particular framework. Next slide. Yeah, so I think that will that brings to end of the presentation. Thank you.
You want to move to the demo, Vineet?
Yeah, I'll just have to share my screen. Okay, you've already. Yeah.
You should be able to share your screen.
Yeah.
Cool.
Just 1 second. So is my screen visible?
Yep, that's good.
So yeah, so this is what you know, the rough UI of FarmStack would look like. So here's a dashboard which gives me the details about, okay, there's a source, there's a consumer, there's a project name, and what are the active policies, and so on and so forth. Then I go on the connector setup. So here uh, I'm saying that this is, you know, the source is basically a DA registry. So I'm a system admin of a DA registry, and I'm giving the name as DAR provider. So what I see is the connector name, the IP and the port, and then the status and visibility. I'll come to what we mean by visibility in a bit. So this is how we can add a connector. So I can deploy a connector that can interface with my database uh, uh, the way. So I'm the data provider, and I want a connector to be deployed on my system, on my infrastructure, that can interface with my data. So I can give a name. Let's say DR provider 2, the connector type, it will provider. Uh, I have to say that identity certificate, I can give the same uh, IP, and I can give the port, and then some sort of a test endpoint or data endpoint, which is let's say test admin, digital green. So this is, let's say, some API, and I can say that make visible. And when I deploy the connector, I have a connector that has been deployed. I see the status that it is secured since I have issued the identity certificate. So it has the credentials, and it is visible. Uh, so I can change the visibility from here, uh, and then I can go on and uh, pair this particular connector to a consumer. So so in this particular case, I have the list of my connectors. So there's a provider 1, provider 2. This particular one is not paired. It has no connector that is paired. Its status is not paired, and action is basically the usage policies. So here, if I want to add a pairing connector, I can go down and I can see what are the list of connectors. So if I've made my connector visible, it will be visible as a list of connectors in FarmStack. So in this particular case, I want to request another connector. So there's one connector that is visible, which is REST advisory, which is a consumer type of connector. And then I need to ping that to test the connection, that this connector will accept my credentials, and this is able to. So there is an acknowledgement, and there is that the connection is established. Now I can pair my connector. So now it is also paired with REST advisory connector. The status has changed, uh, but the usage policies have not been configured. So I need to go and edit the usage policies. If I go there to edit the usage policies, so what I see here is the data route, which is, this is a particular data source, uh, which is DA registry, and then I have consumer, and which is Rust advisory, and there is a workspace one. The workspace one is essentially the container that we are talking about. So it could be some name in the connector world on the consumer side, but for the provider, what matters is that the first container where the data would be going uh, right now has no usage policies. So uh, so we have two types of usage policies. One currently implemented. One is restricted for a particular data application. So I click on that. I configure the usage policy. I see that I can configure as to what application can access this particular data. So what I'm doing is I'm providing a, a container that is a secured workspace, which is not connected to anything else apart from this particular provider, and uh, and there is an application that I can uh, select. So this application has been published by the consumer and is made available uh, to the provider as to what this application does. So I can select this particular application. I need to verify hash, which is basically saying that from the time that it was verified first, uh, does this application has the same sort of fingerprint. Uh, I click on verify hash. I can now submit. If the verification is successful, I can now submit it, and this is how I can configure my usage policies. And I can so in this particular case, the particular application is basically uh, about that it will take this particular data and send Telegram messages through a bot uh, to the specific users. And I can keep on adding uh, further uh, these workspaces, as we call it, and configure more and more data applications, or it can be a time-based access that I want to have this data available for, let's say, this season itself. So next 3 months, and I want to then revoke access or delete the particular data. So with that, yeah, so if I come here, I'll see that the usage policy has been configured. Now, once the transfer is active, and the transfer will be active once at the consumer end, the usage policy is verified that this complies with the usage policies that have been set by the provider. So once that happens, transfer will take place, and it will change the status to transfer active. So yeah, with that, I'll pause here and open up for further questions.
Well, thank you so much, Vineet and Rikin. That was really, really relevant, I think, to where a number of our working groups are right now. So I am sure that folks are gathering their thoughts here, but I imagine that the folks at the RSI team with our recent API switchboard conversation will have some questions to kick things off.
Sure. Can you give me a sense of like the types of data that are connecting through these services? Like it seems like this is primarily built for kind of like real-time sensor type of data, or could it be like a fixed data set? Like some people just output a very large kind of, CSV type data set that's partitioned out, or something that's available like ours is on MongoDB and can be accessed through an API. I mean, how do you imagine this getting used in various types of data? Yeah.
Yeah. So in this particular use case that we have implemented, we have one data that's available through the endpoint in JSON format, and which is like a proper database with the APIs and everything maintained like a real time. The other is actually a CSV file, which is so I can give when I'm running a connector on my server, I can give the path name of the file itself, and that can be read. As we foresee further usage, there will be more and more these data transformation services that will be that will be required to be part of the connectors, and that can be made available. So it will be it will be similar to, as deploying a data application per se on the consumer side. So same way I can deploy when I'm configuring my connector on the provider side, that this is how uh, this is how this particular data format or data set can be interfaced. So right now we have like two disparate data sources, one sort of real time, the other is a file-based system, which is essentially dependent on the user to change that particular file, which is done manually. So it's like a async process there. Uh, does that answer your question, Greg?
Yeah, yeah. Um, yep. And in terms of like the how to, because obviously data transformation is a big piece of this. Data never comes in the way you understand. We've been, and actually Jamie can talk about this more, but we've been looking at different ways to transform data in a sort of easier way. And there's Ink and Switch. They have this really cool idea of like lenses and a fairly simple and straightforward, like more user-friendly way to see data transformations. I don't know, Jamie, like mentioned that, but that it seems like it would be a good overlay for tech or having lens options.
Sorry, I'm having some
Greg
trouble.
was breaking up a little bit there, but I think Jamie, do you want to jump in and talk a little bit about the lens structure? I mean, I think what we're talking about here a bit, and where I was particularly interested in this conversation, is in sort of the handoff between sort of creating some of the common data structures that allow for this level of sort of finer grain role scopes and sort of permissions. And I mean, maybe after Jamie jumps in, I'm particularly interested in hearing more about sort of the sort of how the end user experience or sort of grouped trusts or sort of the admin, sort of scaling the admin in this, and how you see that happen too. But maybe I'll let Jamie jump in here.
Yeah, I don't want to try to put words in Greg's mouth, but I think we're kind of curious. I think prior to assessing certain policies on the data sharing, what ways in which are you sharing that data and then transforming it into some form that another system can then use. I guess I don't know, does your system like take any of that into account, like how, or does your system just say here's the data in a format and it's kind of on you, the consumer, to transform that yourself? I guess, or to rephrase that, are you like mindful of like the ways in which the end consumer might want to have the data formatted?
Yeah, I think if you see the architecture where we say that it's there's a discovery services catalog where these data transformation kind of it could be Node apps or a Python apps which can be published. So simply like if right now I'm showing the end application in this particular case is like a Telegram app, but these apps could come in between. So what happens is that I can create a data route where I say that, hey, look, this is how data needs to be transformed first, then this is how it has to be transformed, and I can say that this particular app is the one that is only required to do that particular process. So so one of the examples could be in in one of the use cases, again in Ethiopia, in wheat, where we had to create a dashboard, which requires a lot of transformation of data in various formats. Like I want to create a time series, I want to create this. So all these transformations can be done using those basic, uh, you know, uh, basic apps that can be deployed in those particular containers themselves.
Mm.
Uh,
Okay, so that's
what
done.
is interesting is that can it go in a sort of rather linear, or it can be a linear data route, or it could fork and then come back.
Mm.
That could be further things, but essentially the idea is that there's a secured space, and these basic transformations are like the basic data applications that can be deployed.
And I guess like relatedly, I'd say, Jamie, like that, like although there's some transformations that we're doing for like some of the specific kind of like use cases that we're kind of standing up, right, in some of these other markets, largely we're mostly kind of like in terms of what's the generic component of like FarmStack, it's mostly the data transfer and usage
Right.
policy enforcement layer,
That makes
right?
sense,
And so
yeah.
like the idea would be to more link with like other people's is like transformations that you or others may have kind of created for like your own sort of use cases, and to basically insert them into that data route framework that Vineet mentioned that like a user could sort of define, but not that we would necessarily digital green like create every single transformation, obviously, because
it would kind of snap on after the
exactly, yeah,
the transfer itself. Then yeah, okay, that's very cool. It's a very cool process.
So, and then feel free to respond to this, Jamie, because maybe you're understanding what they're saying. I think I understand it, but so is it true, like if we build this sort of API switchboard out, so we have a core set of because we're primarily interested in transforming the data into a common format so that we can reduce the number and complexity of APIs between all the services within OpenTEAM. And so that's just a whole bunch of like basically JavaScript scripts, at least initially. So if we kind of build this out, and when we're done, we have, let's say, 10 scripts for 5 organizations, an in script and an out script, data in and data out. Like, could we basically then just bring those scripts to like a structure like that you have and put them in as transformation layers, and otherwise your structure would still kind of work for what we're building out now? I always like to see if like what we're doing now is going in the same direction, or if we're moving further apart. It seems like it would work. But
I think so. Yeah, it would be great to better understand, I think, like how it works kind of in your flow. Are there like different data providers in your sort of ecosystem, each who are trying to do like some kind of, and then perhaps there's different transformations that are happening down like some kind of daisy chain?
Yeah.
If that's correct, then yeah, I think that FarmStack could help on like sort of those transfers. You would still do whatever transformations you all have kind of like implemented, right, in the various ways.
Right.
But if there are some like usage policies that with each handoff you want to codify between 2 nodes in that chain, that again is where like FarmStack can both help to build like sort of that chain and create this policy across it.
Cool. Yeah, cool. And also you have a nice like visual interface, I think, for tracking these things that just is kind of is inherently useful. And we definitely haven't, I mean, certainly OpenTEAM's thought about the data policies, but I didn't have any plans to put at least a sort of switchboard idea at the beginning. So being able to bolt on to pretty cool.
Well, yeah, like, cause just to share, like, I think like the main, difference, right? Cause we've spoken to like people at like Purdue Odes and some of the others, I think we're part of like the OpenTEAM network, right? And I think like they were like sharing also about like their trellis system and stuff. A lot of, I think, of what OpenTEAM sort of the group is working on seems like really decentralized, right? Kind of like direction in general, which is cool, right? And I think the piece of the puzzle that you can potentially add is one, the UI piece, and also how the usage policy from like the data provider ends up being enforceable at the data consumer level. That seemed possibly different. It would be great to confirm
Yeah.
if that's true or not.
Yeah, well, and I'd love, maybe that was sort of what I was trying to get at too a little bit, because what you're starting here is an admin view of that usage policy, but I'd love to hear your vision for both sort of end user visibility in terms of data use, and also sort of, and that part of that is the localization challenge of sort of communicating across languages and geographies and cultures about data use and transformation and so forth. So I don't know if you might want to say a little bit about that, but I feel like that's part of the, you know, the trust bar that you mentioned is also not only doing it technically and then having the code to enforce that agreement, but also being able to communicate in a human readable way how this is all happening. So I don't know if that's, if you've really dove in there, but it's definitely, I'd love to hear your team's thoughts on that.
Yeah, I would say that still early. I can share some of the preliminary thoughts, and maybe Vineet can also chime in. But yeah, basically, like what Vineet demoed was more of like the data provider view, right? Of like setting up the routes and then setting up the usage policies along those routes. But obviously, like there's also sort of a parallel view to that, which is like on the data consumer side, and also so that various actors can have like a little bit of a network view of saying, oh, this data has been shared with this organization and is being used for this purpose, or perhaps some of it has been expired. Some of these like secure connectors no longer are enforceable because maybe the application changed. And so that's certainly a piece of the puzzle that we're currently very much working on, and would be obviously very eager to hear from your side if there are particular types of users that we could be speaking to kind of get some of those requirements. I mean, what we've been designing for are mostly in these markets of India and Ethiopia, where like the farmers specifically have relatively low sort of data literacy, right, with respect to like knowing what is their own data, right? And we're just in the beginnings of trying to build that capacity. But in some of these other sort of markets here in the West, perhaps there's a little bit more sense of that, and we could sort of define these policies and the interface visualizations based on what you think should be prioritized. Maybe I'll ask Vineet if he has additional thoughts.
No, I think Rikin, you mentioned all the points.
Well, and I particularly, you pointed out that you would have sort of various third-party actors that also have visibility, and I wonder, I mean, it looks like the architecture would also support essentially trusted third-party community, sort of community ag groups to help manage those trusted data transactions. So, and I think there are probably, you know, parallels, you know, across scales of ag, where that's going to, you know, regardless of sort of whether it's large scale precision ag or community ag or smaller scale community ag groups and extension groups. But I think that is an important, powerful way to help perhaps share in the workload and reduce sort of the numbers of trusted transactions that are required. So
that's right. I mean, I would say like the one thing, like maybe the nuance there is that, like from the point of view of like creating this trust of just like a pure sort of like peer-to-peer exchange of data, we're I guess our experience has been so far that like people don't want to have sort of intermediate sort of third parties in that flow of data, like including digital green, right? They're kind of scared that like something could get lost or taken out of their hands if that happened, right? But like sort of the notion that we're trying to like gravitate more towards is saying that there could like be like pre-certified apps or third-party services of transformation and the like that these data providers and consumers could build within their routes without needing to do all of the audit of whether this transformation or app service is going to perhaps be malicious and take away some of the usage policies that they wanted to ensure are enforced.
Well, we have a number of people on the call here who are doing participatory on-farm research, for example, and it feels like that would be an example where you would tag specific types of data that farms or ranches are collecting that are part of the research project that just sort of automatically have this permission structure. So you set it up at the outset of the trial, and then all of that data, there may be additional data that farmers are collected that they're not sharing, but all of that data type collected in that way would automatically, so it wouldn't be another barrier on every farmer every time they're at it to administer it. Does that, am I accurately representing where we're
No, that's
here?
right. And I think so the piece that I think Vineet didn't have a chance to talk too much about is about this whole certification thing. And so the way that usage policies and even apps and data providers and consumers are sort of identified to make sure that they're not spoofed, right, is an architecture that is very similar to the SSL TLS kind of framework of issuing certificates. And again, this builds on that framework that we're building FarmStack on called IDSA, International Data Spaces Association. So just as you said, once you've kind of created a set of actors of a particular type, those same certificates can be issued across all of them without having to do it one by one or repeatedly. If that makes sense.
So can I ask one more question?
Yeah.
So a lot of the services that would be connecting to this may already have accomplished some of the goals that your service would accomplish, whether that be integrations with other services or some level of privatization or anonymization of data or privacy of data or something like that. And certainly one of the things that I've learned in trying to talk about this API switchboard idea is that it's often a little bit harder to do it in a collaborative way than for developers to just do it in their own service. So I guess just a very practical question, if you have a existing developed service, do you feel like from the developer's point of view that using the tools that you provided is going to be easier or harder? And if it is harder, can you make a compelling case to those developers that this is worth it? It's going to save you time down the line. It's going to be easier to maintain. You're going to have more extensibility of your piece of software, et cetera. Because that hurdle of developers saying I'd rather just do this myself is such a huge one in these kind of collaborative activities. So I'm just curious your thoughts.
Yeah, I'll let Vineet talk first about it and I can chime in. Vineet, do you want to go?
Yeah, definitely. So I think this is something that few other one of the stakeholders that we have spoken to, they have also expressed. There are different concerns and requirements. So one of the basic thing that FarmStack provides is a way to if I can verify that this is a particular transformation service or a particular application that has been published by a person, and if that can be certified and that can be every time it is deployed, it is verified, it can ease the entire workload. So the idea behind the entire product of FarmStack is to enable this sharing, and one of the aspects is also how to ease it. And if these services, so for example, let's say one of the services that have commonly been asked for is with the stakeholders that we are working right now is related to anonymization, that I can have a service that can remove these kind of fields. Obviously, it becomes a lot more difficult with and depends on different aspects of data model itself. But specifically in the kind of data collaboration activities where the data collection is a lot more organized, and there is a way, there's a standard way of transforming before it can be used. Uh, the entire discovery piece of the catalog of those services uh, can come out to be quite handy for someone to use it. Uh, it can also be, looked in further details, like I can test it out on a specific uh, data set as a, for a specific time, uh, to test out like which service works out best, and then I start using it. So those kind of, modularities or flexibilities is something that would come out of the system itself.
And I would say, like, I think, yeah, as you said, in a collaboration where there are multiple parties, where you don't know each of them, and you want a structured way to like codify your usage policies across some kind of daisy chain, kind of the FarmStack architecture reduces the burden on the developer for having to like enforce or understand every single actor in that whole collaboration. I would say even in the one-on-one sort of interaction that perhaps already is taking place, somebody sharing data with another actor. Okay, in that case, like maybe it's faster just to like have open APIs and they just share it. On the other hand, it still does put a lot of burden on the developer to even do like basic processes to say like, hey, did that data consumer's application change? Are they doing something different from like what I had originally agreed to with how they're using my data? And so again, even in that like really simple, just 2-actor scenario, that's also what FarmStack can help to ease the burden of the developer to say like, you have an automated way to know that this application changed, and that like maybe you now go back to them to say that, hey, is it still like following the usage policies that I followed? And the way that we've designed FarmStack is meant to really piggyback on the work that these people, various data consumers or providers, are already having various types of APIs. It's really not to like replace or change their architecture. It's just really meant to be an add-on to say, here's a peer-to-peer way to share your data with a codification and structuring of the data routes across the various actors or processes that you might have in your flow.
Fantastic. Thank you, Rikin and Sumit, for a great presentation. Vineet, sorry. I think we're at the top of the hour. I see that there's one more question from Jamie in the chat. So I won't close this out, but I just wanted to thank you for joining us today. And we will have a few upcoming in-depths that are focused on community building and also on financing the commons that we're building. So stay tuned for more information about that. But yeah, I'll stay on a couple more minutes if you want to talk about this other question as well from Jamie in the chat. Thanks, everyone.
Thank you.
Thanks.
Sorry, yeah, I understand if folks need to leave, but yeah, I was just curious about that one aspect of chaining connectors, and I guess like how do you prevent like things from like leaking out as you get more and more connectors and providers and consumers involved?
That's a good question. Vineet, do you want to share about that question?
Yeah. So I'll say like at a very top level kind of thing, the idea is that containers are like artifacts which can be created and networked as per the policy. So the policy is defining like what is the sequence of these containers that I'm or the workspaces that I'm creating, and then what is that particular application that will act in that particular workspace. So container connector being that container management layer, it gives usage policy constraints it to create that sequence as has been defined in the usage policy by the provider. So that leads to this particular sequencing as well as what is happening there inside. Uh, uh, what kind of data applications can access the data.
Okay, so could you have like multiple consumers within one connector? Am I understanding that right, or is it not that?
It is, I mean, yes, theoretically, yes, possible that you can have multiple consumers as well. But yes, it'll increasingly become more complex for to manage from the user's point of view. Like if
Right.
if I have to give that, so yeah, it it's kind of if I think of it like uh, other usage policies, a more deeper or different kind of a question, like other usage policies and these daisy chaining is that we are trying to do, is it only possible kind of a peer-to-peer kind of a thing, or it can be done without a peer-to-peer? So the answer is like, yes, it can be done without peer-to-peer, but what the peer-to-peer connector kind of thing gives is there's a complete sovereignty and isolation, and B, sort of ease of maintaining. Like I can say that, okay,
Yeah.
this is the consumer and this is consumer 1, consumer 2, consumer 3. But yes, theoretically you can do that.
So Jamie, I wonder if sort of our aggregator concept essentially does the same thing, but gets to the effect where you have a group sort of permission. Is that, or am I totally off on this?
Yeah. Yeah, I guess I'm thinking of it in those terms. I think, I think it's a big difference when, taking into account the idea of these policies being in place, which I mean, Paul would probably speak better to this because we do have the sense of roles and permissions in the aggregator, but I'm not sure. I don't think that they probably reach anywhere near the level of fine tuning that these policies are able to achieve.
Right. Yeah. They're pretty coarse comparatively. Yeah.
Yeah.
But perhaps that's then the peer connection is actually an aggregator. That's kind of what I was trying to get at with my previous comment too, is that you can have essentially a trusted group that acts as a peer to reduce the transaction load, but could then have that fine-grained sort of scope, but then you have a sort of an admin for that group that's really
right.
Yeah.
And then it hands
Yeah.
off.
Well,
I think,
I think
one thing I'd say is like, like in that use case example that was demoed, right, about like the Telegram thing being like the data consumer. In that case, like, yeah, it was like one Telegram chatbot that is the consumer.
Right.
But of course, there are still many other actual farmers who are getting like those Telegram messages, right? So like when we talk about data consumer, we're talking about like kind of a service level consumer, right?
Yeah.
Which itself could be a group of like many other entities who are availing that service, right?
I guess I'm also wondering, like going back to that example is, I think you used an example of like, there was a group from the, Ministry of Agriculture who was providing those rust forecasts. And I guess my brain is like immediately thinking, well, how are they producing those rust forecasts? Are they, what data what data is that provider a consumer of? They must be getting their data from somewhere, and I'm just trying to imagine like extending that chain, okay, like how are they, you know what I'm saying? Like how do you extend those protections backwards down that chain to the people who are ultimately providing the data to the Ministry of Agriculture?
Yeah, no, and like, so right now we're just starting obviously from the wheat forecast that they've like gotten, but that data, is coming kind of from field-based data collection surveys, right, of like where the rust
Right.
incidents are taking place. And so, yeah, like there could be a layer of like that daisy chain of like saying one step before of saying like those survey agencies, let's just say they want to like maintain some kind of privacy or anonymization or something of like whoever is collecting this data or something, but they want to be able to share it to the government to say like these are the, what can inform your model. Yeah, that is also a use case of like the FarmStack sort of architecture.
That's actually where I could almost see FarmOS aggregator fitting into the chain, even more so than the other end, where you may have an aggregation of farmers who are contributing through one aggregator, some data, and they're going to have a similar kind of concern. So yeah, that's great. Thank you.
No, that's cool. It'd be great. Yeah, I mean, Dorn shared a brief on FarmOS, and obviously super excited about it. And definitely we're talking just along those lines around like how the aggregator service and FarmStack could be relatable.
And this last, what you're describing is essentially from field to transformation and value added back to decision support, essentially, or notifications, is exactly where that's where we're living here, is trying to get to accelerate and create trust all the way around, and provide value so that we have increased the incentive for sharing back to the government higher quality data. So it's wonderful to end on that note. And thanks, JB, for prompting us, even though we've gone over the hour here. So,
for sure, and yeah, from our side, we're super eager to partner and to see how we can, either way, like to bring in like the FarmOS work into our world or FarmStack world into your FarmOS world, whichever, or direction or both. Yeah, we'd be keen on seeing how we can take that conversation forward.
Likewise.
Great. Well, thank you all. I actually have to jump here as well, but thank you again all so much for joining and really kicking off this exciting conversation.
Yeah, thank you so much.
Thanks, Vineet. Thanks, Rikin. Thanks, all.
Thank you.
Thank you, everyone.
Thanks. Bye-bye.
Bye.